Okay, so yesterday we looked at all the movements, all the things that you could do with absolute value. Today we're going to focus a little bit more on the graphs and how they look like, and domain and range, and all of the details that go along with this thing. So, okay, so going back to what we were talking about yesterday with absolute value, the one thing you have to know is that when we're talking about the graphs on this one, the graphs are always V-shaped. And again, you can twist it, you can turn it upside down, you can move it left or right, you can stretch it, you can shrink it. You got all these things you can do, but it still comes down that every single one of these graphs is still going to be V-shaped. So that's the main thing that we do for this one, is that they're always got some V-shaped form or another one. It all comes down to basically one big thing on this one, or two things, I guess, really you could say for this part. Um, so the graph absolute value functions or equations. Okay, so whether it's a function or equation for absolute value, it really doesn't matter. It's still going to be the same thing on this one. Um, again, we need two main things. All right, the first most important thing is to get the vertex. Okay, we're talking about the vertex. Um, that's the point of the V. That basically, if you're talking about a V shape, where the 2 points kind of, where the two rays would kind of pin off this thing. What to say? That's the point of the vertex. Okay, so if we're graphing that one, that would be your vertex right there. All right, second thing that's important, but probably, not quite as important as the part of up here, but you still got to have it for this one. Um, and we talked a little bit again about it yesterday. It's not really slope, but it's kind of like slope. And this is not anything you'll see in a book anywhere. They won't talk about the kind of slope. That's a me thing to talk about in this case, because um, the kind of slope, that is the number multiplied by x. Yesterday we talked about it, that this would basically be like the coefficient. Could be the coefficient. Yesterday they were talking about, the stretching or the shrinking part of it. So it could be like your scale almost in that case. So when we're talking about the kind of slope, that's the number that's in front of x. That's whatever it is that we're going to multiply by on this thing. Okay, and again, here's the difference with the kind of slope part on this one, is that, if we were doing slope, you always went one direction. You went up and to the right or down and to the right when you go through this one. When you're figuring out what the kind of slope is you're going to move up and left for a point. And then also up and right for another point. Okay, but you always have to go back and start at the vertex. Okay, now the up part on this case, when we're doing the up and left and up and right, that's if it's positive. Just like if it was a positive slope, you would always move up and over. Same thing if we're going to graph an absolute value, you're still going to move up and over. It's just you're going to have to move up and over to the left, and then you move up and over to the right to get the V-shaped part of it. Now, if it's negative, instead of going up, you would go down. So it's still that. So that's where we're still kind of like doing slope, because it's still kind of like slope. If it's a positive slope, you would move up and over. In this case, you're going to move up and over left and right to get the V-shaped part of this one. If it's negative, you're going to move down and then left and then down and right to get the V-shape because it's going down for that part. Okay, so that's where it's kind of like slope, but it's not technically slope, because slope is for just a linear equation. Absolute value, it's the a value that they're going to call it when we go through this thing. All right, so standard form is basically this. It's a times x minus h plus k. Okay, and they'll tell you that a is your direction, and again, for this part of it, for what we're going to talk about, a is your kind of slope. Again, you won't find that in any book, but just kind of think about it that way, that it's kind of like your slope, but it's not exactly like your slope. It's kind of sort of that way. Okay, and again, the h value that's here and the k value that's here, the hk is your vertex. So yesterday when we were doing all the movements and knowing if it was inside and outside, what it was going to do in that case, that was kind of tying everything back in there. Okay, so when you're getting your HK, your H is your horizontal movement from 0. And to me, it always kind of made sense because I've got H and it's horizontal. To me, it would have made perfect sense if they had said this being K, it would have been V, because V would be your vertical movement. Why it's not V, I don't know. Because if H is your horizontal movement, to me, it should be H plus V, and then that way you know that V would be your vertical movement. Why it's not V, I don't know. That just, that kind of bothers me on that part of it, but it's not. So K is your vertical movement. So again, this tells you the H value tells you how much you're moving side to side. Your K value is how much you're going to move up and down from the origin. Okay, so there's where we're tying everything back into what we did yesterday. That we talked about, the H was your opposite horizontal movement. Again, remember when we're doing this one that even though it's horizontal, it's still opposite horizontal because it's a minus in the formula. So because it's a minus in the formula, when you pull it out, it's still going to be the opposite direction. So if it's a -3, you're going to go 3 spaces to the right on that one. Or if it's a +4, then you're moving 4 spaces to the left. So it's still that opposite horizontal movement. If we'll go through those. Okay, so now here's where we're going to go back and use our graph paper that you've got. Okay, so there's our standard formula, or standard form. And again, what we're going to have in the homework, and we're going through test questions and all those other things, it's going to ask you to graph y equals x minus 2 plus 4. Okay, and finding the vertex on these should be like one of the easiest things we will do this year from absolute value, because all you're going to do if you have to find the vertex is you're going to take the number that's inside the parentheses, pull it out, and just change the sign because, again, it's opposite direction. We're going to go 2 spaces to the right. Whatever number's on the outside, that's the second part of your vertex. All right, so vertex is at 2, 4, so we go over 2 and up 1, 2, 3, 4. All right, there's not a number in front of the x, so that basically means that in that case our coefficient or a value would equal 1. And if we do it kind of like slope, that means it's 1 over 1. So to get the V shape from the vertex, we're going to go up 1 and over 1 to the right. We're going to go up 1 and over 1 to the left. And there you go. That's all you got to do. Okay, now here's where we're going to tie in with what we did in the last test that we were doing. Still going to tie in domain and range on these. Okay, so domain, again, we're left and right moving. How far are we going to the left? Negative infinity. How far to the right? Infinity. So any absolute value we're going to do, the graph, the domain will always, always, always be negative infinity to infinity every single time. That will never change. There's nothing they can do that will ever change an absolute value graph that won't always be infinity, negative infinity to infinity. The only thing that's going to change is your range. And that's going to be depending on how you move this one. Because for this part of it, the range is our up and down movement. Well, the lowest point we get on the graph, that would be a minimum point, right? So if they were going to ask, I don't know if they'll ask that yet, but that's probably coming up the next couple of days. Our vertex in this case would be a minimum. Because again, it's at the bottom of the graph. So we'll go ahead and kind of talk about that too. So when we talk about the range, it starts at the bottom and goes up to infinity. So we're going to start with our y value of 4. And we're going to go to infinity. And in that case, we do get to put the square bracket on that y value because we actually get to touch that one. So the easy thing in this one today, when we're going through all the absolute value, if they ask you about the range for any of these, you do get to put the square bracket on that. Everything else is going to be infinity or negative infinity, so you use parentheses. But when we're doing the range, whatever this number is, it's at the bottom, you get to put a square bracket because it should be a solid dot there. All right, everybody all right with that one? Seem like it's okay? All right. Let's give you a few more here, just to make sure we got it. So the absolute value of x minus 3. Okay, no number on the inside. So that means h value would be 0. Got the negative 3 on the outside. So 0, negative 3 is the vertex. Okay, again, a value, which they probably will not ask you for. Still 1, so it's still up 1 over 1 on this thing. Okay, so we're going to go to 0, negative 3, 1, 2, 3. That'll put us right there. A value is, again, understood to be 1, so we're going up 1 over 1 to the right, up 1 over 1 to the left. And there you go. And there's your graph. And again, graphs, that's as easy as it is for the graphs on that part. Nothing tricky at all about anything graph-wise on those. All right, domain and range. And a lot of times on this one, they may not even ask you about the domain because I think they'll kind of, after you do enough of these, you'll realize real quick the domain's always negative infinity to infinity. That part's not going to change, so they probably won't even ask you for domain in a lot of these questions. The range, again, is the only thing that's going to change. So in this case, the vertex is at the bottom, so that means that would be a minimum point. So if that's a minimum, that y value is the lowest value we get, so that's negative 3 to infinity. There you go. All right, a couple more of those just to make sure everybody's got it, and then we'll see what we've got after that. We got -2 times the absolute value of x. Okay, no numbers behind it, so vertex is at 0, 0, so that didn't change any at all. Our a value in this case is -2, but again, we got to think about it kind of like slope, so that's -2 over 1. Okay, so vertex is 0, 0. Again, we're going to go down 2 over 1 to the right side, down 2 over 1 to the left side. So we're going to graph something like that. All right, so where's the vertex now? All right, yep, it's at the top, so vertex is a maximum point now. Okay, domain, again, not going to change any at all. It's still -infinity to infinity. All right, but your range, if that's the max point, that's as high as you can get. So this time when we do a range, we're going to start, because it's going down forever, it's -infinity, and we're going to get to 0, and then we get to stop at 0. So if it's a max point, if the vertex is a max, that's going to be the highest point in your range. If the vertex is a minimum, that's going to be the lowest point in your range. Because again, it's the minimum point, so that's got to be the lowest y value. If it's the maximum point, that's got to be the biggest y value. So that's where they're tying in those values and making everything kind of go on that part. All right, one more. Let's go with absolute value, or 1/3 times the absolute value of x plus 1 minus 2. All right, for the vertex, change that sign from +1 to -1. Make that a -2, so there's our vertex. All right, and a value is 1/3. So again, we start with our vertex, start at -1, -2. All right, so it's 1/3. So we're going to go up 1 and over 1, 2, 3. And then from the vertex, go up 1 over 1, 2, 3 to get that. Okay, and there's where you can actually start to see what we were talking about yesterday. That if we do this where this is less than 1, this is where yesterday we were talking about, the stretch or the shrink on this case. This is where you can tell that it's compressed, that this thing is now out really wide compared to, how this one looks. So if it goes out wide like it is here, that's where we would talk about this thing being a compression or a shrink, whichever way they want to say it there. Where if we were doing this one, we had the negative over here. So that was the reflection part of it. And then the 2 would basically be a stretch, because if we were to compare this graph to one of the normal graphs, it's going to be a little bit taller. It's going to be a little bit narrower than if we did, if we just did negative absolute value of x. It would be more like this. You don't have to write this. I'll just go back and erase it here in a second. But if we just did negative absolute value of x, it would be like this, and then you can see that -2x is going to be inside, so it's going to be a little bit skinnier than this graph is. And that's the part that's hard to see. If they don't give you something to compare it to, you don't really know if it's a stretch or a shrink. Now, sometimes like this one, you can tell because it's definitely way out wide from the other graphs that we had. But some of these, if they don't give you something to compare it to, you don't always notice it too much. Okay, so we got -1, 2. Again, vertex in this case is at the bottom, so that is a minimum point. Domain, again, never changes. It's still negative infinity to infinity. At the range, since that's the minimum point, that means that's the lowest value in our y values at -2, and that goes to infinity. Sorry. Okay. And doing one other graph here. We'll do this at the bottom real quick. This is where we'll tie back into some of the other stuff we're doing. If it's an inequality, if it's equations, it's always a straight line. If you've got one that's an inequality, here's where you've got to break it down a little bit. Now, vertex is still going to be the same. So change the sign, make it positive. That sign stays the same. So your vertex is still going to be at 3, 2. Your A value is still 1. The difference is when you go to graph this one, because it's y greater than, that's going to tell you two things. First thing is it's going to tell you that that's a dash line when you graph it. The second thing it tells you is because it's y greater, you're going to have to shade up. Okay, so when you draw the graph, if you're drawing here at the bottom, draw it so it looks a bit more like that because the graph is going to be more down this way as we go through this thing. Okay, so the vertex is at 3, 2. Hang on. Sorry about that. Make that a minus. So I've got that. I drew my box over here wrong. That was going to throw things off a little bit for that one. So that's our x and y axis. Should have made that a -2 to start with. Should have moved. Anyway, I messed up when I drew my graph here, so we're going to just change that to a -2. Okay, so let's go to 1, 2, 3, -2. Okay, A value is 1. So again, we should be going up 1, over 1 to get this point. Up 1 point to the left to get the next point there. Okay, again, big difference is when you're going to draw this one now. It's not a solid line when you draw your V shape. It's a dash line. Okay, and because it's greater, anywhere on the line, again, doesn't matter where you go, anywhere on the line, just like we did before. You start anywhere on the line and you shade up. So that means that's going to be everything kind of on the inside of the V-shaped graph there. Okay, so if they throw inequalities at you, or if I throw inequalities at you, again, still that same concept we were doing back in the last chapter of dash line or solid line depends on, if this has got the bar underneath it, then you just make it a solid line. It's still that same thing. If it's greater than, you're going to shade up from the line. If it was less than, we would be shading everything underneath the bottom of it down here. Again, it doesn't matter, which way the graph goes. Just to throw one at you here real quick. If you had a graph like this where it was, y would be, that's still a greater than. Negative x -3, -2, something like that. If we had a graph of something like that, again, the difference is when we drew this line, it would be going down over, but it's still greater, so you'd shade on the outside, so it would be something like that. Okay, so inequality just means you've got to shade it either up or down. It's still going to be the same setup. You're still moving it. These two values move the vertex where it needs to be. A value still tells you how to move to get to the next point, left and right when you go through those. But again, now it's the inequality part, so it determines dashed or solid line. And again, that one tells you whether you're shading up or shading down. All right, and then the last little thing that we're going to throw it in here just because, well, it doesn't really fit anywhere else. We're just going to throw this in here somewhere. If you want to put that on the back side, again, it's just a random little topic that we've got here that you can just throw in, somewhere here. But it's a piecewise function. Okay, and a piecewise function sounds like it's what it is. It's a function that's made up of different pieces. So it's just a function that has different rules for different parts. Kind of like when you get your driver's license. When you turn 15, you can drive as long as there's an adult in the car who's got a driver's license, and you've got to stay that way, for a while. And at 16, is there still restrictions now at 16? There's like certain times. Okay, so you technically only supposed to have one other person in the car with you. So it is.
Well, one non-family
member. Okay. So there's different rules. At 15 you got to have an adult in the car with you. At 16 you can only have one other person in the car with you. Yeah, once you get to 17, then the rules kind of change from that part of it. I know different states. I think even like in Virginia, there's like certain rules of if you're 16 in Virginia, you can't be out driving by yourself after like 10 p.m. or something. And it stays that way until it's 16. Then when you get to 17, it changes. All right, so piecewise function, different rules for different parts of it, and a lot of times they're going to show it to you like this. Okay, so instead of the function just being, f of x equals something, and again, they could put p of x or f of x or g of x. It doesn't really matter. A lot of times they like to put p because it's a piecewise function. But you've got two pieces. You've got 8x and 12x plus 60. And then what they will do out beside it is they're going to say, all right, you're going to use this function if your x value is between 0 and 40. And if your x value is greater than 40, you're going to use this function. So they kind of define where you're going to use. So depending on what your x value is, you get this certain piece of it that you're going to use. So if the x value is between 0 and 40, use this thing. If it's greater than 40, you're going to use this thing. All right, now here's the big check on this one. Here's the big thing you got to know. Because it's still a function, it doesn't really matter for this one. Because it's still a function. If you plug in one number, you still only get one answer. Because a lot of times the biggest thing people will do for this one is we'll give you, and I'll show you the second one, we'll do in a second, is it will tell you to evaluate for a certain answer, and they'll give me two answers on this thing. No, it's a function, so you still only get one answer if you plug in one number for this one. So they'll do something like this. They'll just tell you to evaluate P of 10. Okay, so with evaluate P of 10, basically here's what you've got to do. Here's the question, is where does x equals 10 fit? Because again, even though, so when they give you a value, you basically just ignore this for a minute. So they're telling you that basically where x value is 10 here. So where does 10 fit? Is 10 between 0 and 40, or is 10 greater than 40? Obviously, it's between 0 and 40, right? So since it fits into the 0 and 40, yeah, the x value would fit there. That means you have to use 8x. So we're not going to use that part of it because it doesn't fit in that part of the equation. So since it fits here, you've got to take the x equals 10 and plug it back in here. Okay, so they tell you to evaluate p of 10. Answer is 8. Okay, and that's for piecewise function. That's pretty much all you do. You just figure out, all right, where does it fit? Where, they give me an x value to plug in. Where does it fit? And whatever part it fits into, then you use that function that correlates with that inequality that you're going to work with. All right, and then the last thing we'll do here, let's say we're going to find p of 41. Okay, so again, we got x equals 41. In that case, 41 is greater than 40, right? I mean, that's pretty obvious what we're going with there. So in that case, since it fits with this part of the inequality, we've got to use that part of the function to plug this thing in. Okay, so we're going to use the 12x plus 60 part. So again, we're plugging in x equals 41. So it's 12 times 41 plus 60. So it's 492 plus 60, which would be 552, if my math is correct. Okay, and so that's all piecewise function is they're going to give you something that's got, again, maybe two, maybe three, maybe even 4 parts to it. And you just got to figure out which part of the inequality it fits with, and then take that answer, the x value you got, plug it back into that part of the inequality that it fits with, and give me that one answer there. And again, big thing is, you give me one x value, you only get one answer. You don't plug it into every single part and piece of it. You guys have to figure out which part or which piece of it will fit and make it work out the best it can there.